Repeated measures data comes up a lot in doing research, and it's when something's recorded on the same thing, and you might want to think of an animal or something. You've measured it at baseline, you measure it at several time points, because you want to see if something's having an effect at different times, how long it takes to have an effect. So this is actually some measurements taken on crabs, and they had different diets, and these are the mean values after different time points, and the person plotting this graph would put in standard errors. So that constitutes repeated measures data, because the data are taken on the same crab several times and they can't be considered to be independent. And you might think, well, that's simple, I'll just fit the crab identity in my model and that'll be fine. And sometimes it is possible to use that model, but only if the data are complete, because you need to be very careful not to treat this data as independent because it's coming from the same crabs. You need to take that into account. So what are the possible approaches that you might use? I mean, one thing that would do, but it's not ideal, is you might get a summary statistic for the data. So you might say, well, I'll take the average of my data over the whole, this is some other data that's repeated measures, over the whole kind of range of values for each of the individuals, and I'll take the mean. You might consider the area under the curve, the maximum value, the time it takes to get to the maximum value. Or you might say, well, I'm actually most interested in analysing the data at this particular time point, I'll analyse that. So that's all right, but it's a bit restrictive. You know, you've only got one value, and if you've got missing data, you might, for example, miss the maximum value or the time point where you reached the maximum. What a lot of people do, I mean, people that aren't statisticians usually, they will just go ahead and analyse all the time points separately. If you're lucky, they'll adjust for multiple testing. And the disadvantages of that is that you're doing repeated tests, and what happens if you get a significant result at one time point and then you do the next one and it's non-significant, and then you go to the next one and it is significant. It can be a bit confusing, and it's possible that some of those were significant just by chance. But nevertheless, people sort of like to do that. But I think you do need to bear in mind the possibility of getting a result by chance, because you're doing multiple testing. If the data are complete, you can, as I mentioned on the last slide, use a general linear model, but you would then need to make sure you adapt your test for comparing the treatments to make sure they're compared between, using variability that occurs between the individuals and not treating the observations as independent across time. And it really can't be done if the data are not complete. It doesn't work. But there are packages that will allow you to do this properly for complete data. You'll see sort of repeated measures analysis of variance as an option. But a way that will work is to use something called a mixed model, and that's suitable for both complete or incomplete data. You're not having to resort to just getting one value for each of the individual animals or units.